bit more confident to like go through the papers and also, refer to like the full recordings so that at least you know what's in there and what to expect. Because remember, it's still the same person. So, anyways, with like this one, right? It says the roots of the equation, the roots of an equation. So, meaning the solutions, right? So, hence you have a plus and a minus there. It's given by this whole thing here. So, let's see. This is like negative n square root of n squared minus 4mp, the whole thing over 2m, right? Now, with all this being written out, let's see what we can do. They said with all this written out, let's move calling here. Don't know what that is. Anyway, so they said here with all this being written out, they said x is equal to whatever this is going to be, right? And then it says here m, the variable m, the variable n, and the variable p, those are all positive real numbers. And then they say those numbers in this order, right? M, N, and P in that order form a geometric sequence. So since you may not have like dived into the number patterns, the one thing you can already remember is that anytime you're dealing with the geometric number pattern, you are going to need to remember that a geometric number pattern has a common ratio, you see. So a common ratio refers to how, for example, in the sequence, right, you'll have m as the first thing, and then n comes after, and then p comes after, you see. So that being known, you already know that as long as this is a geometric sequence, you always want to make use of the question to help you see what you're going to do. So they say this form a geometric sequence, and we should prove that x is a non-real number. We should just prove that x is a non-real number. So proving that x is a non-real number is just a matter of proving that this has no solution. You see, so here we have to somewhat prove that this has.
Is that almost always going to mean that if it is a non-real number that it has no solution?
Yeah, because when they say non-real number, they're trying to say the solution does not exist. Like there's no answer for this question. So yeah. So here, the one thing we can just lean on is if this is a geometric sequence, let's utilize properties of a geometric sequence. A geometric sequence, we will know that n over m is equal to p over n, p over n. And then from just this, we can see the only thing that looks like can come out from here is if you cross multiply here, right, you're going to end up with like n times n, which is n squared, m times p, which is like mp. Okay, so this is all we have here. It doesn't look like anything is happening there. So just looking at this though, fine, let's just leave this the way it is. Looking at the question again, if they said here we should show that x has no real numbers or has non-real, x is a non-real number. Here we said prove that this has no solution. So if you're looking at the expression that we have here, right? Anything that's for this to not have a solution, right? We would want to focus on the one thing that determines what kind of answers we get for this expression. So for example, if we're looking at what we have here, right, we already know that anything under a square root, this part here that's under a square root, for this expression to have a solution, this part here has to be bigger than 0. You see, the n squared minus 4mp. N squared minus 4mp has to be bigger than 0 for your x to have solutions. So in reverse, we'll have to say n squared minus 4mp has to be smaller than 0 for x to be a non-real number, for x to be a non-real real number. You see, because x being a non-real number is all determined by this here. Because as long as this is a negative, your x won't have any solutions. So x will be a non-real number. It won't be any value. So that's what we just have to do for these 4 marks here. We have to work out where we have to work out where n squared minus 4mp. We have to work out where is it smaller than 0. So this one is going to be a bit tricky because so far, I mean, like looking at what we have, I mean, yeah, it doesn't look very promising because if we're working out where n squared minus 4mp is smaller than 0, and then from what we have here, we said n over m is equal to p over n. Cross multiplying this gave us n squared is equal to mp. So if you like, if we're being a bit extra here, we could even end up throwing n squared here where mp is. But then, yeah, I think that could work. Let's do that. So here we have to work out this expression because we're working out where this is smaller than 0. So when we see nm, right, we already know that when we see mp, can you see that mp is n squared?
Yeah, wait. Okay, yeah, yes, yes.
Yeah, so we can name this maybe equation number 1, right? So whatever we know here, n squared is just mp. So here you can say n squared minus 4. Replace this with n squared. It's easier if we replace the mp here instead of us replacing the n squared. Because if we throw mp where n squared is, we're going to be working with 2 variables, which is like, you know, it's not IOBA. So it's easier if we work with like just 1 variable. So here, this is going to be n squared minus 4n squared, right? I don't know, I'm rewriting that, but it's like technically 1 minus 4. So that's going to be like -3. -3n squared. And then here, if we're going to work out what we're going to work out, let's see, solving for n here, we're going to have divide both sides by the -3. Let's see what we end up with. -3 n squared. Because we're dividing by a negative, the inequality sign has to flip over, you see. So this is going to be a 0. And then here we're going to have square root of this, square root of that. So this is like n is bigger than 0. So, but let's see now. I mean, like for 4 marks, I don't think this is very conclusive. I don't think this is very, what's that word? Yeah, it doesn't look concrete enough to say that we've answered the question. But let's see, the roots of this equation are this. And then they told us that prove that this, okay, where m, n, and whatever are positive. Oh, they say these are positive, right?
Yeah.
But then, okay, yeah, this is saying n is bigger than 0. Okay, fine. Where all those are positive real numbers. The numbers m, n, and p in that order form a geometric sequence. Prove that x is non-real number. So we work that way. N squared minus 4mp is okay. So let's see. So this is what we have right on the. Let me see here. Let me just tell this person to please text me. Hold on. Let me see here. You can text. Okay, hold on. So let's see. What do I need here? Wait. Oh yeah. So we said for the next, if this is not like giving us something that makes sense to answer our question, what we can do is let's try and see what comes out from this without doing anything. N squared minus 4mp smaller than 0. So if the minus 4mp goes to the other side, we will have here 4mp. And then from here, let's see, n squared smaller than 4mp. Whew, for 4 marks, I think for 4 marks, You might be overthinking the question a little bit. The numbers n,
Although this is
m,
kind
n.
of nice seeing you also rack your brains like this.
Dude, I wreck my brains all the time. Yeah. I don't know if you haven't noticed, then I don't know where you've been all this time. But then
No, you breeze through everything. You breeze
what?
through everything. It's like you look at something,
Wow.
answer, finished. And I'm just like, okay, thanks.
Wow.
Yeah.
Wow. Okay. So let's see. Okay, no, it's fine. I mean, like, what I'm trying to say is, what you may call. Let me see. Because I mean, the push comes to shove. I can always just double check what I wrote when I went through this, you know. But now because that's not there, I mean, gotta do what you gotta do. So let's see. But what you will see now is, you see, anytime you'll see me stuck, the one thing you'll see me do is go back to the question and then just read it again. So it says here the roots of an equation this, where m, n, and p are positive. Where m, n, and p are positive real numbers. The numbers m, n, and p in that order form a geometric sequence. Prove that x is a non-real number. Okay, proving that x is a non-real number. N squared is equal to m times p. And then we said here n squared smaller than 4mp. Yeah, let me see what I wrote. I'll figure it out. I mean, I figured it out already, so I don't think figuring it out again is a point. But anyways, I think let's just see what was written down for this particular question, and then we can just move on. But then I think also this highlights that with like pre-recorded material, it's more streamlined, because remember, with pre-recorded material, it basically means that any unnecessary info was like disregarded. You know, it was not like left in there. So for example, now if we're looking at this question, let's see what I wrote here. Okay, fine. So it looks like we did the same thing, right? N squared is equal to mp, and then we worked this out. It's saying negative mp is smaller than 0. But then here it says if m and p, wow. Okay.
What happened?
Oh, I see the logic behind what I had I was thinking. So it looks like here, what you may call, it looks like, okay, so remember they said p, n, and m are all positive numbers, but then here this is the expression we have. It says, remember we have this expression, or we had this expression also, but then here I remember I replaced mp with the n squared, but then here it looks like I replaced the n squared with the mp, because now if it's like that, then we have here negative 3mp, and then it says if m and p are positive, then 3mp will always be a negative. Therefore, x is a non-real number, because this is trying to say that this will never happen. You see, because m and p will always be positive numbers. So if you put positive numbers here and you multiply them by a negative 3, you're always going to come up with a negative number. Let's see, if m and p are positive, then negative 3 will always be a negative value. Let's see, therefore x is a non-real number. Really, that's kind of interesting, because if negative 3mp will always be negative, what does that do now? Let's check here. Negative 3mp will always be negative. Negative 3mp will always be negative. Oh, okay. So if you look at what's under our square root, right? Remember what goes under our square root is this whole thing. You see, remember this whole thing is what goes under our square root. So if you check what we have here, we can actually just start from here, because I think now it makes sense. So if you look at what we have here, right, the part that's under our square root is this part here. Let me just do this. This is the part that's under our square root, right? N squared minus 4 MP. So we worked out that N squared is equal to MP. So the part that's under our square root here is technically going to be MP minus 4 MP. You see, of which this is going to be negative 3 MP. And then we said M and P will always be positive numbers, you see. So if you say a positive times a positive and you times the negative 3, we're seeing that this here will always be a negative number. You see, this will always be negative. And then as long as this is always negative, it means that we will always be putting a negative under a square root. And as long as we're putting a negative under a square root, we know that we'll always have no solution. You see?
Okay.
Yeah.
I feel like I
Yeah.
remembered something about that. I just didn't know how to put it into words.
Yeah, I think I mean, it happens, you know, I guess it happens. So, yeah, because I think, again, I can always go back to how it looks as though pre-recorded material. This is where pre-recorded material shines, because obviously I would have cracked my brain wherever, however, but then if it's recorded, I mean, like once it's edited, that whole cracking the brain part is usually like chopped off, because what's the point of, you know, seeing just 5 minutes of blank screen, you know? So yeah, I think that's the method to the madness behind all that's out there for you to be able to use. Cool.
Yes.
Okay. So